students, but let's just get started and hopefully some more can join. But welcome everyone back to the 8th and final class of Java Level 2. So you're almost at graduation, which is you should really be proud of. I will start class just like normal with a little bit of a review, as well as kind of going over the homework, but it's a little bit different this week. The main thing I just wanted to focus on was, okay, actually wrong slides right here, but these are the slides I wanted. So last week, I introduced what I called the principles of object-oriented programming. And so that's the OOP in the middle. And we had these 4 principles. And so up to this moment, in our 7 classes, we've kind of covered 3 of these, the ones at the top: polymorphism, encapsulation, and inheritance. I was wondering if anyone could tell me anything about any of these 3. So you can choose one, whichever one you want, and maybe one sentence like, what is it all about, or why is it useful, or why do we care, right? I say these are principles of object-oriented programming. These are really big, like powerful things. So I was wondering if anyone could help me remember what they're all about. I think polymorphism might be the one that we spent the least amount of time on. Inheritance, we probably spent the most time on. And encapsulation is kind of just a fancy word of something that we've kind of seen already a lot. How about with the kind of the easier one? Stephen, can you tell me what inheritance is all about? Maybe like how you do it or why, anything.
Well, inheritance is a child program getting the same traits as the parent program.
Yeah, that's perfect. So it's very much like genetic inheritance in that in programming, we have these classes and we have a parent class and a child class. And so I just want to add a little bit more the terminology, but your idea was completely right. So we have parent classes and child classes, and the child class inherits the traits of the parent class. Specifically, we said these traits are the methods and the fields. So methods are just the Java methods that we've written before. They kind of do some sort of function typically. And the fields are just variables. They store information. Yeah, so that's exactly inheritance. Next, I'm going to go counterclockwise. Encapsulation. So this is kind of a fancy word. I was wondering if anyone remembered what this is all about. One word that's related to encapsulation is about visibility. Encapsulation deals with visibility of things. So I guess maybe a less open-ended question is, Andrew, what things have we seen in Java that control the visibility of fields or methods? We had these modifiers that we put in front of them, and we talked about 2 of them more than others. Do you remember what they are? Yeah, thank you, Andrew. Private and public, yeah. So encapsulation is all about the idea of basically hiding some values or hiding some sort of methods from other people. You want to do this because it can avoid clutter. And so this basically like, you don't want all the variables just floating around, all the methods floating around, but also kind of for security. For example, if you have a class that's storing your bank account and your balance, you don't want some random guy to go in and change the value, right? Or, I mean, maybe you do if they increase your balance, but like, what if you had a program that's storing people's social security numbers, something that should really only that person knows, right? You don't want everyone knowing what your social security number is. So you don't want to store it into a public field. Because if you store it into a public field, anyone can see it, anyone can change it if they wanted to. Instead, you might want to store it into a private variable so that only the class itself is able to interact with it. Yeah, so that's encapsulation. And then polymorphism. Does anyone remember what it means breaking down? So what does poly mean and what does morphism mean? Maybe Michael, can you help with that? What does polymorphism mean?
I missed the last 2 classes, so.
Oh, okay, no
yeah,
problem.
Not really.
How about David? Do you remember what polymorphism kind of means or stands for? Close. It's actually very similar. Poly does mean many, and morph kind of means like forms or shapes. In programming, what that refers to is essentially one thing, like for example, a method, working in multiple different ways. And so we saw 2 different versions of polymorphism. The one that we've seen a long time ago was compile time polymorphism with method overloading. So we learned how to write methods that were able to essentially take in different numbers of parameters, input parameters. So you could write like an add method that takes in 2 things, but you can also write an add method that takes in 3. And so combined, it's like one method still, but you define it in 2 different ways. And depending on how you call it, it does different things. We also saw runtime polymorphism with inheritance. And so that was what we called method overriding, where the parent class defines some sort of method, but the child class can also define it. And what happens is when the child like redefines the method, essentially what happens is that when the program is being run and when the child calls that method, it inherits the one from the parent. But instead of using that one, it uses the one that was redefined in the child class. And so that's why it's method overriding. It kind of overrides the old method. Right. Yeah. So those really are the 3 kind of principles of object-oriented programming that we've seen so far. Today, we're going to talk about the final one, abstraction. Before we do that, I do want to just have a little bit of comment about the homework. So last week, I told you guys to essentially make sure you completed week 6 homework with inheritance. And I saw a lot of people submitted stuff for this week, which was great. And I saw some really creative stuff, some really good questions. I tried answering them really like 10 minutes ago, or at least like 20 minutes before class started. So you might not have seen my comments yet, but please take a look. If you are still confused, let me know. But since it really was an open-ended assignment, you could have done whatever you wanted. I don't have an example to share here, but if you want, the examples that we've done in class are kind of examples that you could have done for homework, like with our car and convertible or automobiles, trucks, the inheritance structure that we have. I do want to take a pause though. If anyone has any questions about kind of these 3 topics, inheritance, encapsulation, polymorphism, or the homework, or really anything else that we've covered thus far in the course. All right. So I'll give a couple more seconds as I talk, but you can leave a message in chat, you can speak up, you can private message me, anything that you want works for me. But the last topic for really Java 2 is this abstraction idea. And let's just jump right into it. So looking at the slides, abstraction in Java takes a couple different forms. So the first one that we're going to talk about is abstract classes and abstract methods. So what is an abstract class? Well, you might have heard the word abstract before in just English language, such as like abstract art is probably maybe where you've heard about it. But abstract just typically means something that's like kind of intangible, right? So in Java, we can see here, the opposite of an abstract class is a concrete class. And so everything we've written so far is a concrete class. It's like tangible, it's a real thing. For example, our car class, that's like a real thing. Cars are a real thing. Abstract classes, on the other hand, kind of can be real in some ways, but in other ways, they're kind of not well defined. They're more of just an idea rather than a concrete thing. And so abstract classes, they're denoted by the abstract keyword. So when you say like public class car, you would put abstract up there. So you could say like public abstract class car, whatever. And when you put the abstract keyword, it just says it's abstract class. There are some special things about abstract classes. So an abstract class cannot be instantiated, which, as the slide says, means that you're not able to create objects of that type. So if you say a class is abstract, you can't make objects of that class. It kind of doesn't make sense to. And we'll see a little bit more clearly why later on. So that's really what an abstract class is. But I think to understand this more, we also have to talk about abstract methods. And we can build back up to abstract classes. So I actually want to talk about this first. Abstract methods, kind of related to classes. You define them by just putting abstract at the beginning. So instead of public void a method, you put abstract, right? This, if I can highlight, is something that we've seen before, right? This is a public method, has no return type. It's called a method, and it doesn't return anything. It doesn't take in anything as parameters. But we have this abstract in front of it now. And so what in the world is this? So abstract classes, abstract methods, sorry, have something that looks really odd at first. They don't have a body. So if we remember, method bodies is basically everything between the curly braces. So if I go to Eclipse, if I can open that up, yeah, here's something that we had from last week. This is the method body, right? This is another method body. Here is another method body, a pretty big one here. So abstract methods don't have this. They don't have a body. What that means is how they work, what they do is not defined, which should be a little bit weird to you. But this is really where we get to the idea of abstract, right? They're abstract because they're not fully defined yet. It's just an idea of a function, but the actual implementation, the actual steps on how to do it is not defined. We don't know how it works. And there's really good reason for this, right? This is not just because like we're lazy and we don't want to define it. There's a good reason why we have this whole abstract structure, this abstraction. And so if we go back to the slides, in general, we use programming to mirror the real world objects. And objects share behaviors. So like the example on this slide is if we want a Java class that represents animals in general, animals we know, they pretty much all have some way to move around, right? Like humans walk or run, birds can fly, fish swim, they all move, but they do it in different ways. And so what you might want to do is, hey, I'm defining an animal class. It makes sense because animals move. But at the same time, I don't know how it moves, right? Because I don't have a specific animal yet. Like, I'm just defining the animal class in general. I'm not talking about a particular type of animal yet. So I don't know how they move. So they do move, but I don't know how. So that's where abstract methods come in. You just call the method abstract and you say, hey, I will write the body, I will write the actual implementation later on, right? I don't know how to do it yet because I don't know what animal this is. But some point down the road, I will know and I will implement it then, right? This is also why an abstract class can't be instantiated. An abstract class, I didn't say this explicitly, what makes a class abstract is that it has abstract methods. So if your class has abstract methods in it, it's automatically an abstract class. The Java forces you to put abstract in the class declaration. And now it should make sense why you can't create objects of an abstract class. It's because it's not fully defined yet, right? If we go back to this animal class with this abstract method move, if we try to create an animal object and call move, then we get stuck because the move method exists, it's there, but it doesn't do anything. It doesn't have a body. And so it kind of gets in this weird state. And so we just don't allow it to happen. We just don't allow you to make an animal object if there's abstract methods in there. You can only instantiate concrete objects. And concrete in the sense means that everything has been implemented. So all the functionality is there. In an abstract class, the functionality might be incomplete. You can have fully finished, fully complete methods, but you might also have methods that are not yet fully fleshed out yet, right? For example, I think one of you guys, maybe Andrew, was doing like with the inheritance kind of a warrior system where you have different like types of soldiers. You might want an abstract method called like attack, and different types of soldiers attack in different ways. So if you have a parent class, that might have an abstract method. And then the children will actually implement that method later on. And that goes back to what we talked before with polymorphism, overriding. Essentially, you take your parent class, you inherit the method, and then you override it. You write your own version that actually implements that behavior. That's just an example. We can look at actual code as well. So here is an abstract class, right? So it's an abstract class because we have abstract, right? But more than that, it's abstract because if you look inside the class, we have an abstract method. Okay. So here we have a public void myAbstract method, and we called it abstract, right? This is just the method name. We could have called it anything, but this is what makes it abstract. And because it's abstract, we don't have curly braces. We just put a semicolon after the parameter list. Okay. So as you can see, this is what an abstract method looks like. It's not defined. It doesn't have anything, right? All it has is the name, what it takes in, and what kind of thing it should return. But it doesn't actually tell you anything. It doesn't actually implement the actual method. It just has a skeleton there, right? And then this is just to show you, an abstract class doesn't have to be fully abstract. You can have concrete methods in your class. And not to confuse you, you can have constructors in your abstract class. You just can't use them, right? You can define them and they're there. You're allowed to do it, but you just can't use the constructor. Yeah. What's the point of adding them? So I got a question. What's the point of adding them? Assuming why would we add constructors to an abstract class? That's a really good question. So it might sound really dumb, like if we can't create objects of this class, why would we ever create constructors? Because they're not going to be used ever, right? So I think the answer to this is that in general, abstract classes are not things that stand alone. You generally pair abstract classes with a concrete class. When you write an abstract class, it's generally so that you can use inheritance and make a child of the class that's not abstract, right? So abstraction and inheritance go really hand in hand. You usually don't keep a class abstract forever. You generally will at some point have a child that implements the abstract methods. And so when you do that, the child will inherit the constructors that you write. And so if you want like a shared constructor between all of the children that will implement this abstract class, that is why you might want constructors, right? Even though you can't use them yet, if you write them, then the children will get it for free. And then the children can use the constructor to implement to instantiate an object. Does that make sense why we might want constructors in an abstract class when even though we can't create abstract objects? Yeah, awesome. Cool. Yep, so next slide. Yep, so this next slide is kind of what I was talking about actually. So when you make abstract classes, you generally will have classes that extend it, that inherit from it. And when a class inherits from an abstract class, you have two options. You have to either implement the abstract methods, or you have to declare the class abstract as well. And if you think about it, this should make sense, right? Any class that inherits from another one, whether it's abstract or not, any class that inherits will have all the methods and fields of the parent. And so if the parent has an abstract method, you inherit the abstract method. So since you have an abstract method, you have to be abstract. However, you can override it. You can replace it with a new method that's not abstract, right? So if you don't do that, you inherit the abstract method, you have to be abstract. But if you do implement it, if you do override it, then you're no longer constrained. You can be concrete as long as you implement the methods. You can't just pick and choose. You have to implement everything or you're abstract, right? It's all or nothing. What you can have is maybe a parent that has 5 abstract methods, and then down the line, you can have a child that maybe is still abstract, but implements 3 of them. And then you can have a child of that one, which is now the grandchild of the original one, that implements the remaining 2 methods. And so you don't have to do them all at the same time. But until you implement all the abstract methods, you have to be abstract yourself. And so you can't create objects of that type. The slide also talks about the Java numbers class. It's an example of an abstract class in Java. If you want to take a look, I'll paste a link in chat, but I don't think it's too important at this moment. I want to just go to Eclipse to show an example of me really typing out this idea of abstract classes. So let me open up this, and first of all, let me fix the errors. I'm gonna delete this. Let me make a new Java class. And I want to show you what it looks like. Oops, not an interface. And so the name, I don't know, I'm going to call it animal because that was the example on the slides. And at this point, you can just tell Eclipse, hey, I want this to be abstract, and it will put the abstract for you. But I'm going to leave it alone because I want to do it manually. And here you go. So here we have a completely blank class on my screen. This is something that we've seen before. Doesn't have anything inside of it yet, but nothing special. And so I'm not gonna put the abstract at the top just yet. I'm gonna put some normal class stuff. Maybe I want a constructor for this class. And so if you remember, the constructor has to be public. It has to be called animal. And maybe the constructor takes in, I'll just do a no argument constructor, or actually I'll do one. So maybe I have a field like string name, and the constructor takes in this like a parameter n, and what the yeah, typos everywhere. So there's a field name. I have a constructor that takes in one input, and I'm gonna store that into my field. So name equals n. Right? That's my constructor. And then maybe I want a concrete method in this class. So maybe I want a public print name method, and I forgot the return type should be void. And all this is going to do is print out my field. So system.out.println name. And now I want to add an abstract method. The thing that we talked about before, maybe a move method. So this one, I'm going to say abstract. And then I do the normal stuff. I want it to be public. Void is probably fine. Or I'll make it, yeah, I'll make it void. And then I'll call it move. And since it's abstract, now I put a semicolon, right? Because I'm done. Right? I don't have to implement the body like I did for these methods because it's abstract, it doesn't have a body. However, I still do have an error. So if I hover over this, it says the abstract method move in type animal can only be defined by an abstract class. And so what this is saying, I have two fixes. I can either make this non-abstract or I make the class abstract. Okay. If I look up here, it says the type animal must be an abstract class to define abstract methods, right? I can't have a non-abstract class that has abstract methods. If you have an abstract method, you are an abstract class, right? Period. No exceptions. So because I added this abstract method, now I have to make my class abstract. Right? And once I do that, all the errors go away, right? It was all just complaining about this. I need to make my class abstract. At this point, I can save this. I can go to my runner class, and maybe I want to try creating an animal object, even though I know I can't, right? So if I do animal A equals new animal, and the constructor takes in a string, so maybe just do my name, you'll notice I get an error, as you might expect. And if I hover over it, what does it say? It says, cannot instantiate the type animal. It really isn't a helpful error message, but all this is saying is, hey, this class is abstract. I'm not allowed to create animal objects, right? It's abstract, it's not concrete. So what do I do now? Let me make a concrete class that inherits from this one. So I want to make like a human class. So I'll make class human, and this extends the animal class. Right? And so at this point, I have an error, right? If I just have the curly braces, nothing inside, can anyone tell me what the error is without me hovering over it? Why is this a problem? What am I missing at this point? All I've done right now is inherit from animal, but it's saying I have a problem. Why do I have a problem? Close, it's not about the constructor. Well, okay, so it does give me an error for constructor. So, okay, so I was wrong. You do need a no argument constructor, so I'm just gonna make one here. But even if I add a constructor, it still has a problem. So I added a no argument constructor. This error is now no longer because of constructor reasons. Can anyone tell me what's wrong now? I mentioned it earlier. So think about what happens when we extend a class. In general, whenever you inherit a class, what happens? You get all the fields, you get all the methods. So why is that a problem? Why is it a problem that we're inheriting the methods from animal class? Awesome, thank you, David. So you hit it exactly on the spot. We inherit this abstract method, this move method. However, this class is not abstract, it's concrete. So we need to fix this somehow. What we can do is, well, the cop-out is we just make this class abstract, but this isn't what we want. We want to implement the method actually. So what does that look like? Let me show you. Here, all I want to do is just say public void move. And now it's not abstract. I need to put a body. And here I'm going to say like system.out.println name walks. Right. And now if I go back to my runner class, I can try something different. So now instead of trying to create an animal object, I can create a human object. So I can say human, and I'm gonna call it H because it's a human. Human H equals new human. And oh, let me see what's going on. Oh, what's going on here? Oh, I need to make a constructor. So public human string n. All I want to do is call super and then n. So what this does is it calls the animal classes constructor and it just passes the string here. And now if we go back and we run this, we can do h.move. And if we run this, what do we see? You can see this prints out the message that we wanted. So this is an example of an abstract class with an abstract method. Special things about it, the abstract method has no body, has no definition of what it does. It defines everything else. It defines the visibility, it defines the return type, it defines the name, it defines the inputs, but it does not define how it works, right? Yeah, okay, I'll get to your question, Andrew. Then, because we have the abstract method, we have an abstract class. Because we have an abstract class, we can't create animal objects. It's not allowed. Java prevents you from doing it. To get around that, we create a new class that extends the animal class. And this one actually defines what move does. Right? Here's an abstract method. Here's the concrete version. You can imagine maybe I want a different class. Like I can define, I don't know, a fish class. And has a fish constructor and the move is the name swims, right? So if we go back to runner, let me make a fish object now. Fish f equals new fish. Unfortunately, fish do not walk. Maybe Nemo, and capitalize that. And if I do f dot move, and I run it, you can see it says Jack walks, but Nemo swims, right? So again, this is an example of polymorphism. It's the same method, it's the same move method, right? We say h dot move, and then we say f dot move. But because h is a human and f is a fish, the move method is defined differently. If you were careful, you might notice like, hey, we could have done this without abstract classes, right? There was nothing that having abstract classes allowed us to do that other classes, like having concrete classes only didn't. I think the best way to put it is that the advantage of abstract classes is that it kind of enforces you to follow the rules. So if we didn't have abstract classes, then we might get sloppy. We might accidentally make an animal object when it doesn't really make sense to. We might forget to implement some of the methods. And so by putting the abstract thing, Java kind of forces you to do the right thing. Then, getting back to the question that Andrew had. Andrew asked, what does super do again? So I didn't talk about this much before, which explains why we have this confusion. And super is just a really confusing thing in general. But what super does is it basically is a reference to the super class. And so here, fish extends animal, which means the super class is the animal class. Oh yeah, sorry, my screen was frozen. So the fish class and the human class for this case, the super class is the animal class. And so when we call super, it's kind of a function actually. It's kind of a special function, you can think of it that way. But what super does is it basically gives you an animal reference. So when we say super, this really means animal. And then what goes here is passed on to the constructor of that object. And so when we say super n, it's basically calling the animal constructor, and it's passing in this variable to the constructor of the animal class. And the same thing goes here. So maybe something that doesn't make sense, but will show off some stuff. If I change the fish class to extending human, right, it doesn't make sense to do that at all. But let's just try doing that, extends human. Now this super doesn't refer to animal anymore, it refers to human. And to show that off, let me just put some stuff. Let me print out system.out.println animal constructor. Right, so I just want some messages letting us know which constructors we're calling. And last one, fish, right? So whenever this constructor is run, we will print out this message. Whenever the human constructor runs, we will print out this message. And whenever the fish constructor runs, it will print out this message. So if we go back to the runner class, when we create these objects, let's see what happens. Let me open this up a little bit bigger. That wasn't really what I wanted, but it works. So here, the human constructor calls this. But then the fish constructor says this. It calls the fish constructor, but it also calls the human constructor. And that's because we have this super. And the reason why I didn't say animal is because I put it in the wrong constructor. I was a little bit confused, but this is the one that we're actually calling. Yep. And so you can imagine you could have multiple constructors and super can figure out which constructor to use. But yeah, and this goes back to, I think, the error that we had before about constructors being weird. In general, whenever you have a child class, it implicitly does super with no arguments. It does this automatically. If you don't write it, it puts it at the front of your constructor by default. And so this causes a problem if there is no argument constructor in the super class. This is why sometimes you just put a no argument constructor in your classes so that the super call doesn't mess with it. Right? You can't get rid of it. Even if you delete, like even if you don't write it yourself, it's put there for you. And so you either have to use super yourself or you have to add a no argument constructor. But that's technical details, not too important. Yeah. So that's a really quick demo of abstract classes. The last topic of abstraction is kind of just really similar to abstract classes. So what that is an interface. So it looks really different, like the abstract classes to interfaces. That sounds really different, but it's really just the same thing, just kind of the next level. So all an interface is it's just a completely abstract class. So we said that abstract classes can have a mix of abstract and concrete methods. Well, an interface only allows abstract methods, right? It's a completely abstract class. So every single method, well, I say this with a grain of salt, but pretty much every single method in an interface will be abstract, has no body. And because of this, there's kind of a shortcut. First of all, we define an interface by saying interface. So this is no longer a class. It's a different thing. Really similar to it, but it's technically different. So we say interface. And then each of the methods in the body, we don't have to put abstract because it's there kind of implicitly. Because it's an interface, all of the methods are abstract. So we don't have to put it there. We don't have to type abstract every single time. It's a shortcut for us. So these are all abstract methods and they just have no body. So with an interface, there is no constructor. You can't create objects of it. That's very similar to abstract classes. All of the methods are abstract and public. You don't have fields and it's not extended. So that's a lot of things. The important things to remember is that all the methods are abstract and that you can't create instances of it. There's a couple of reasons why you can't. One, it's not a class, but two, it's abstract. So even if it was a class, you can't create instances of interfaces because they're abstract. They're not fully defined yet. And the last thing that's important is how to use them. They're what's called implemented rather than extended. And so what does that look like here? Well, this is actually not a good example. Do I have an example besides? I don't think I do. So let me do this. So I'm gonna make a really simple interface that doesn't really do much, but I can say interface, and then like my interface, right? This will not really do anything interesting because I can't come up with anything on the fly. But I create my interface. If you have nothing, that's a fine interface, but it's not really useful. But you can say the interface has a public void method, my method, right? And then maybe it has another public, maybe an int method called max, and it takes in an int a, int b, right? And then you can define as many methods as you want, but they're all abstract. And then when you want to use the interface, here we say class human extends animal, but then we can also say implements my interface. And when I do this, this causes an error because this is the same thing we had before. Oh, I think my interface with a capital M. This causes the same error as before because this class is not abstract, but now I have these abstract methods. you can think of implementing very, very similar to extending. Essentially, you just get all the methods in the interface into your class for free. And so since now we have these abstract methods, we have to implement them, or else we have to be abstract ourselves. And so really the way to think about interfaces is that they're just a special case of the abstract classes. They're just a fully abstract class. Some more differences. Types of methods. Interfaces can only have abstract methods. They're fully abstract. This thing is not as important. Implementation. So abstract classes, oops. There we go. Abstract classes can actually implement interfaces. That's because abstract classes can have concrete methods. Interfaces, though, can't implement classes because they can't implement anything. They have to be abstract. Here, interface is used by the word implements, while an abstract class is used by the word extends. So you extend classes, you implement interfaces. Otherwise, other than just the word, there really isn't that much of a difference on how it works. It's just that extends versus implements idea. One thing that is interesting is that you can only extend one class. You can only have one parent, but you can implement pretty much as many interfaces as you want, right? So you can implement 10 interfaces if you wanted to, right? And so that's actually the slide right here, multiple implementation. So in abstract class, well, classes in general, you can only extend one. Interfaces, you can extend many, you can implement many. And so kind of the last thing about interfaces is, again, why do we care about interfaces? Why are they useful? Why have them over abstract classes, I guess? So really, again, it's kind of just a design choice. It's really useful in kind of standardizing how things work. If you really think about what an interface means, it's kind of like the thing that you're interacting with, right? So if you think about your car interface, you have a dashboard, you have a steering wheel, you have a radio, right? You have something that you're familiar with, that you know how to work, you know how to use, right? You know basically how to use a steering wheel. You know how to use a gas pedal. You know how to use a brake, right? You know how to turn on the radio by pressing on the button. You might not know how it actually does all those things, right? You might not know how turning the steering wheel turns the wheels, or how pressing the gas changes all the things in the engine to make it go faster, right? You don't really care, to be honest, right? All you care is having that interface for you to work with. And so that's really what programming interfaces are for as well. So one interface that we've kind of seen briefly is the collections interface. So Java has this built-in interface called collections, and a lot of things implement it. So array lists, I don't know if we actually talked about it, but they implement collections. I think arrays do as well. But the collections interface has a lot of things defined in it. The collections interface defines an add function. It defines a remove function. It defines a sort function. It defines a lot of things. So basically, if you know something implements the collections interface, you know for sure it is able to add elements and remove elements. It's able to sort the elements that is contained in it. You might not know how it does it. Different implementations can do it differently. And maybe each different implementations have different advantages, right? But it really doesn't matter. What matters is that you know that there's kind of a guarantee that whatever object, like I can swap out my collection with another collection, right? Because as long as I'm adding things, removing things, sorting things, it doesn't really matter which collection I'm using. I can just swap them out of my code, easy peasy. I know for sure it won't break anything else, because anything that implements collection will satisfy the requirements for my project, for my code, right? And so really that's like why we have interfaces, right? Why abstraction is really powerful. It kind of allows us to have these building blocks, allows us to have these guarantees, and really it's like it might not make a lot of sense at the beginning, but once you create like bigger projects, you really appreciate having this in Java and in languages in general. And so this slide talks about like Java harder than Python. I'd say Java is a little bit harder than Python, but really once you start understanding these, like you'll understand a lot of programming languages, which is really cool. And yeah, the last slide, small detail. Interfaces technically can have methods that define bodies, but this is really like a corner case and I haven't really used this at all. So I don't think of it as really important at this point. But if we go back to one last coding example, maybe for interfaces, let's talk about this. Let's try to make a new, I'm gonna make an interface here and I'm gonna make it like the geometry interface. So the geometry interface, what it does is maybe it has a public int get perimeter, and it also has a public int get area. Right. So if you implement this geometry interface, you have a get perimeter method, you have a get area method, guaranteed. And so let's create some classes that implement this interface. Right? So I'm going to create a new class and I'm going to call it square. I'm going to create this. And if we do this, I'm going to say the square. I'm going to make a constructor, public square. I can type, and it's going to take in a double side, like, oops, sorry about that. So as a field, I'm going to have a double side length. And all this is doing is it's going to store the whatever I pass into the constructor into the field. Okay. And now if I add implements geometry, now I get some errors, right? So whenever you're implementing interfaces, you're going to get errors at the beginning. Essentially, it's just saying, hey, you're not done, right? You have to actually implement this interface. You told me you're going to do it, but you haven't done it yet. So right here it says, hey, the type square must implement the inherited abstract method geometry.getArea. So let me implement it. I need to define a public method that returns an int called getArea. And for a square, that's just going to be the side, like return side length times side length. And so actually, if I go back to my interface, I'm going to make these doubles because my square has doubles. So if I go back here, and everything, here we go. We implemented one of the methods. We can implement another one, public double get perimeter. And this one should just return 4 times the side length because each side is the same length. And now if I go to my runner class and let me create a square object. Oops. Let me get my computer up. Square s equals new square, and maybe it's like 5.2, and then system out.println s.getArea, right? And then perimeter, you can imagine it's just the same thing. But so if I run this, proceed, you can see my display is a little bit messed up, but let me just reset the perspective. we can see, if I run it again, that it prints out 27.04. That's apparently, it makes sense, that's the area of the square, right? Now, if you can imagine, I can create like a circle class, I can create a triangle class, I can create a lot of different shape classes. And if I implement geometry for each of them, I basically have a guarantee that whichever object I'm working with, whether it's a square, whether it's a rectangle, whether it's a circle, whatever, they all have these methods. I can get the area of all of them. I can get the perimeter of all of them, right? And so that's why we have interfaces. Right? It allows you kind of a guarantee of these are a set of things that you can do with these families of objects. They might do it differently, but you can do it with all of them, right? And so that really is the end of today's class. So in the remaining minutes, just some housekeeping. So there is no homework for this week because it is the last class. If you're interested in continuing to Java 3, you will have to talk to Ms. He about it. Unfortunately, I will not be teaching further for this series. So I really do want to take a moment to thank everyone for sticking with me. I got some really great questions and interactions this semester. If you want to stay in touch, if you have questions about programming, want any questions or any help, I'm still happy to connect even after the class is over. I can drop my email in the chat. Let me put that there. So if you want to reach out with any questions, I'll still be available. But that's all I had. So thank you everyone for showing up today. If you have any questions, as always, I'll be sticking around to answer them. If not, I hope you have a great day and yeah. All right.
Thank you. Bye.
You're welcome. You too, Andrew. Yeah. Thanks, Stephen.
So I have a question.
Yeah.
So like, since I missed the past two classes, I want to go back and like do the homeworks. So would you still be able to check, like give me feedback on those or no?
Yeah, sure. So the Google Classroom site should stay up for a while.
Okay.
It shouldn't be deleted anytime soon. But yeah, if you submit, maybe since I won't be checking regularly, either leave a comment when you do submit or send an email so I know that you've submitted, so I can get back to it as soon as I can.
Okay.
Yeah.
Thank you. Yeah, I'll do
Yeah.
that. Yeah. Thank you. Bye.
You're welcome. Bye. Thank you, Missy. I think that was everyone. So I'll see you next Monday. Yeah. Bye.